We're continuing with Chapter 1 on data collection. Section 1.3 is on simple random sampling. So in this section, we definitely want to learn what a simple random sample is, and we also want to learn how to use TI-84 technology to obtain a simple random sample. To understand what a simple random sample is, we need to look at both types of just general random samples here, or two types here. The first one, just a random sample. And the definition of a random sample, got it more neatly here than I could write, is the process of using chance to select individuals from a population to be included in a sample. Each member of the population has an equal chance of being selected. So that's all that's required, is that there's an equal chance. You'll see how that can be done differently when we look at our two examples. Okay, so in the first example, we have a classroom of 4 rows. See, the rows are horizontal, and 6 students in each row. And we're to select 6 students by selecting a row. So each student has some fraction of a chance of being selected. This is where our probability comes in. If they're choosing by row, row 1, row 2, row 3, or row 4, each student has a 1 out of 4 chance of being selected because they're in one of those 4 rows. If Sue, Ann, and Pat are on a different row from Bob, Lou, and John, and they're all friends and they're hoping that they are going to be the 6 students selected, first, do we conclude that every student has an equal chance of being selected? Yes, every student has a 1 in 4 chance of being selected. It's equal for each student. But does every group size 6, say every group of 6 friends, have an equal chance of being selected? Well, no. Sue, Ann, and Pat, if they're on a different row from Bob, Lou, and John, there's no way that those 6 will be selected if you select by row. So no, we can't get every possible group of 6. Okay, we're going to contrast this with the definition of a simple random sample. Well, let's look at this definition. A simple random sample. Let me see if I can move it up a little bit. All right. A simple random sample is taken in such a way that each sample of size n of the population has an equal chance of being selected. Okay. Each sample of size n in the population has an equal chance of being selected. Not just each member, but each possible sample, every group of 6 friends, for example. Okay, so back at our example, if we have a classroom, the same classroom with the 4 rows of 6 students, but now instead of choosing by row, we're going to put all their names in a box on a little slip of paper, right? And we're going to draw a name, 6 different names out. So each student has what chance of being selected? Well, we're going to draw 6 names out of 24 students, right? Which simplifies to 1/4. So it is the same chance, but there's a difference. Here it's every student has a 1/4 chance, but they come in groups of 6, not just any group of 6. Here it's a 1 in 4 chance, but there are unlimited numbers of 6 groups of 6, right? Well, it's limited, but it can be any group of 6. So again, if Sue and Ann and Pat are on a different row than Bob and Lou and John, they're hoping to get us selected. Does every student have an equal chance? Yes, every student has an equal chance. Does every group of size 6 have an equal chance? Yes. So this is the only way that all 6 of them could possibly be chosen. This way they could not. The simple random sample. This is the important sampling type for our applications in this course. When we get into some of the theories that we'll study and the tests we will run, hypothesis testing, confidence intervals, it will always be required that the subjects were drawn using a simple random sample. So in this one, the probability of getting Sue, Ann, Pat, Bob, Lou, and John is 0 because they're not on the same row. But here we could compute the probability of that group. We'll continue in the next video.